In this lesson, we'll briefly cover the components of the radio navigation systems, including the Vhf Nav System for VOR and ILS navigation, the distance measuring equipment DME system, the automatic direction finding ADF system, the radio altimeter system, the air traffic control transponder system, and TCAS. But the radio management system, VHF COM, and associated voice and data communication systems are covered in Module 16. The nav systems are mostly tuned from the ARC2s or the FMS and display indications on the PFDs and on the MFDs, with oral idents routed to the audio integrating system via the ARC2s. They also output to the GPS. For interest, here are most of the antennas used in the radio nav and other systems. Firstly, the upper. Note that the VOR lock antennas are on both sides of the vertical stabilizer. Now the lower antennas. The VHF nav receivers, NAV 1 and 2, supply VOR or ILS data, depending on frequency selection, from VOR, VOR DME, or VORTAC ground stations. Station tuning is manually, via the main page of the ARC2s, or auto-tuning via the VOR particular page from the FMS. On the glare shield flight guidance control panel, you can select independent nav sources, VOR ILS or FMS, for either side, and independent course pointers for either side. Outputs are the nav source annunciator, nav frequency, the bearing pointers, and reminder labels. There's also the course pointer set by the course knob, the course deviation bar computed by comparing the nav source bearing against the selected course, and course deviation scale, 5 degrees per dot on a VOR frequency, and 1 1/4 degrees per dot on an ILS. And there's the to from pointer. On an ILS frequency, the VHF Nav system gives you localizer and glide slope indications. The system also automatically receives outer, middle, and inner marker signals, displays them on the PFDs, and plays their idents via the audio integrating system if the ARC2 marker volume was selected on. Distance measuring equipment, DME receivers 1 and 2, function independently and continuously to supply slant range distance to a DME equipped ground station by measuring the time for a signal to travel to the station and back. Tuning and selecting a VOR or ILS frequency on the ARC2 automatically selects its paired DME frequency. The DME system also supplies data from multiple ground stations to the FMS to calculate its position fixing algorithm. It also feeds into the ATC transponder system and into TCAS. As usual, you can listen in to the station signals and control volume on the ARC2. DME volume level is displayed on the VOR particular page. Outputs on the PFD and MFD are distance to station and time to station. Ground speed is displayed on the MFD only. If a station is not equipped with DME, or it malfunctions, its DME readings are replaced by white dashes. In this case, you can hold the distance from a working station and navigate to another station by using the DME hold push button and tuning the active frequency, as described in the ARC2 lesson. you see the H indications reminding you that you're in DME hold mode. The Automatic Direction Finding ADF system gives automatic point-to-station bearings to a fixed non-directional beacon. ADF receivers 1 and 2 are tuned by the ARC2 or remotely by the FMS. ADF bearing pointers are selected with the bearing knobs on the EFIS control panels. You can listen to their signals via these volume controls. The bearing pointers are displayed on the PFDs with the usual reminders. You can select ADF parameters on the ADF particular page. ADF is normal and gives bearing pointers and audio. Antenna only receives audio signals. ADF pointers are parked at the 9 o'clock position. BFO on provides beat frequency oscillations for operation with CW stations. A 1000 Hz tone identifies the station. Operation is the same as ADF mode with the bearing pointers normal. This window lets you select tuning increments of 0.5 or 1 kHz. During the test, the bearing pointer for the ADF you're testing is parked at 9 o'clock. After the test, you'll see the OK message for 5 seconds or the fail message. The radio altimeter receivers RA1 and 2 function independently and automatically to calculate the above ground level altitude for use by the AFCS system, the stall protection modules, and the ground proximity warning system, as well as recording radio altitude on the flight data recorder and on the maintenance central diagnostic system. Outputs on the PFDs are the radio altitude, shown by the analog radio altimeter rising runway, the digital radio altitude, and the decision height with its flag. Decision height is set on the index control panels. The radio altimeter system is also responsible for mismatch and failure flags. The mode S stands for surveillance, transponder system, replies to interrogations from ATC ground stations by transmitting a signal to identify the aircraft and its altitude parameters. It also interrogates and replies to interrogations from other TCAS-equipped aircraft. Aircraft ident can also be squawked when requested by ATC to help them to find you on their screens. The system uses 2 transponders, ATC 1 and 2, one active and the other in standby, and 3 possible modes. In mode A, the active transponder transmits only aircraft ident. In mode C, the transponder transmits only ident and encoded altitude information. But in the normal mode S, it transmits ident, altitude, max airspeed, and TCAS information. The operating modes of the transponders are controlled by the ARC2s and the FMS. The air data units also supply altitude data. Squawking ident back to ATC can be done from the ID button on the ARC2, although it's usually done from the ATC ident remote buttons on the control wheels. When ident is activated, the transponder will squawk ident for about 17 seconds. Displayed on the ARC2 ATC window are the active ATC label, so ATC2 is on standby, the active transponder code and the pre-selected code, the transponder mode, on or standby, and ALT if altitude reporting is on. When transmitting an ident to ATC, ID appears next to the pre-select code. ATC parameters can be changed on the TCAS ATC particular page. This window selects the altitude source, ALT1 from ADU1 or ALT2 from ADU2. Here we're using ALT1. Off switches altitude reporting off, and ALT is removed from the bottom ATC window. You toggle through the three options as usual by repeated pressing of the side key. This window lets you select the active ATC. The other will be in standby. And this selection will switch both transponders to standby. In standby, you'll see SBY in the bottom window. You can simultaneously test both transponders on ground only by selecting both to standby and pressing the side key for test. You get OK or fail messages. The OK goes away after 5 seconds, but fail stays until retested or electrical power is removed. Finally, you change the pre-select transponder code with the tune knob in the usual way, and press the side key to swap the new pre-select with the active transponder code. Note that you should not operate the transponder with a code of 4 zeros, or the emergency codes starting with 7, unless you really mean it.